So concept 2 is all about series and summation, and we've seen summation before. It's that sigma symbol. So we're going to work with that a little bit and understand what that means. So our objective for this section, or this lesson, is I can evaluate the sum of a series expressed in sigma notation. So we've seen sigma before when we did standard deviation. Not the lowercase sigma, but the uppercase sigma. It looks like a backwards E, sort of. Okay, so our objective is I can evaluate the sum of a series expressed in sigma notation. So there's two things. There's finding the sum and then understanding what sigma notation means. Okay, so a series is, let me zoom in a little bit, the sum of the terms in a sequence. So basically we've learned about what a sequence is. Now a series is you're just adding those terms together. That's all it is. Okay, so we're given some examples of sequences here, and we're going to find the series. So for this one, this is a finite sequence. We know that because there's no little dots telling us it goes on forever. It ends right after 4. Okay, so the series would be 1 plus 2 plus 3 plus 4. We're just adding all the terms together. That's it. Okay, so 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Okay, so we're just adding the terms together. This one, 3 plus 6 plus 9 plus 12 plus on and on forever. If it goes on and on forever and I keep adding more and more numbers that are bigger, that goes on until infinity. I can't add, because all of these are bigger than 1, and they're bigger than the last one, I'm going to keep adding and getting a bigger and bigger number up until infinity. Okay, so whenever you have whole numbers like this, you keep adding, that's infinity. This example over here, these fractions are getting smaller and smaller. So if I add 1/2 plus 1/4 plus 1/8 plus 1/16 plus on and on. So I start out with 1/2 and I add a 1/4, and then I'm there, so that's 3/4, right? Then I add an 1/8, so I'm adding a little bit more each time. This sequence here, the series of this goes all the way to 1. If I keep adding forever and ever and ever, smaller and smaller fractions, I'm going to get closer and closer to 1. Okay, so, and I can explain this a little bit more. If I add whole numbers, I get to infinity. If I add fractions, and I start out with a fraction, I'm going to get closer and closer and closer to 1. This is sort of like that asymptote thing. I'm going to keep adding and adding and adding smaller and smaller increments, so I'm never actually going to get to 1, but if I keep adding forever and infinitely, I'm going to get 1 as my sum. Okay? So the partial sum is expressed S sub n. So I'll write that down, S sub n. And a partial sum is exactly what it says. Oops, I should move that over so you can see it. It's exactly what it says. It's the sum of a specified number of terms. Okay, so it only wants a partial sum. Say you want the sum of the first 8 terms, the sum of the first 10 terms, something like that. Okay, it will tell you how many terms they want. So let's do some examples here. I'll do the odd ones, and then in class we'll do the evens, okay? So find the partial sum for each given sequence. So find S sub 9, which means I need to figure out the pattern, first of all. What's the pattern in the sequence? And then add up the first 9 terms. So these ones, they keep going up by 1, 1, 1, 1. So I know that the first 9 terms are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. I know they keep going up by 1. I found the pattern. Okay. To find the sum of the first 9 terms, or S sub 9, I just add all those together. Well, I know from up here that 1 plus 2 plus 3 plus 4 is 10, plus 5 is 15, 21, 28, 36, 45 is my sum. I just add them all together. Okay. So let's do this one, number 3. What's the pattern here? Well, this is going up by 3, up by 5. You know what's even easier than that? Let's list them as terms. So 1, 2, 3, 4, 5. I'm seeing a pattern right away. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we know that the sequence is n squared, right? We're just squaring the numbers. They want the sum of the first 6 terms. So we know that the next term is going to be 36 because these are all the perfect squares. And we're going to add all these together. So s sub 6, 1 plus 4. So to help you out, I'll write it all out. 1 plus 4 plus 9 plus 16 plus 25 plus 36. Okay, we're going to add all those together. 1 plus 4 is 5. 5 plus 9 is 14. 14 plus 16 is 30. 55. 55 plus 36 is 91. Okay? So that is how you find the partial sum of a sequence. Okay, so in the next video I'll get into summation notation.